tell me if I go out of the, because that's recording in the right frame. If I go out of that, like if I move the paper, tell me, because it'll go out of the recording space, frame, spot.
Why
Okay.
is it only recording that tiny little dot?
It's recording this area right here.
Is it recording what you're saying right now?
Uh-huh. Everybody say, hi, Christina.
Hi, Christina.
Okay, that was awesome. All right. You have this in worksheet form, and you'll be taking a quiz on this tomorrow. I thought I was going to maybe get to it today, but I don't think I've done enough practice with you. Also, those of you taking AP tests, here's what I've done to help you plan for this. I know we have AP tests for some of you guys on Monday, AP Chem, right? Chemistry kids? Okay, that's a few of you. Wednesday is AP Calc, right, for a bunch of you? Yes? A couple nods? And Friday is that? Okay. So Monday, Wednesday, Friday for a lot of my juniors are going to be AP test days. So we're going to take the A test on Friday. I will make it, woohoo,
Really, really easy.
kind of. Not going to make it really, really
And
easy.
for everyone.
I will do my part to really, really prepare you so that you, you're welcome, so that you can pass the A test and not have to worry about it during AP testing week.
That's awesome.
Does that sound good?
Iron Man 3 comes out the night before.
I know. What did I do all weekend? Watched Iron Man 1, Iron Man 2 to get prepared. And then you have to go see the Avengers, too, because it's like a continuation of the Avengers. All right. So, I love the Avengers. Space, okay, Glimpson Miznik is actually a teenage boy. Now,
Do you want me to grab your ticket?
how much? No, I'm not, I can be patient. I'm not going Thursday night.
Friday morning.
Here's what I need from you. Stay with me this week. Pay attention. If you're taking AP tests for sure, this will make your life so much easier. Are you with me? If you're not taking AP tests, wouldn't it be great to pass the A test anyway? Okay.
On 3
Okay, now don't be inappropriate, John. Well, maybe I thought you said something different than you said, so never mind. All right. Sorry. I can tell by the look on your face you're stymied, which means I thought you said something else. Okay. I believe you, John. Okay, let's see. Everybody's like, what? What just happened? Okay. So here we have a compound circuit. First step should be find the equivalent, it's called the equivalent or the total resistance, first step. So how would you do that? How would you find the equivalent resistance? You look at a couple resistors at a time that you know the relationship. Which ones do you know the relationship? Which one? Yeah. Speaking of relationships, if you're in one and holding hands right now in my class, are you able to focus?
Sorry.
Okay. Evan and Justin. What's that equivalent resistance? Why is it 1? Good question. Yeah. 1/2 plus 1/2 equals 1 over denominator. No worries. All right. Now what? Add the 1 and the 2 and the 1. Those are all in a series, correct? 2, 3, 4. Got it?
So where would the 1 be if we didn't add it? If we wouldn't add it, where would it be? Yeah.
I do not understand your question.
Okay, so we add the 1 on the side.
This one over here?
Yeah, why
Yeah.
do we add that 1?
Why?
Yeah.
Because it's in this contiguous path. It's in series. If there was a junction here, then it could be parallel, but it's in this. It's as if this is one simple wire, one loop. All right, so total resistance is 2, 3, 4. Second step is find the current coming out of the battery. Current coming out of the battery, and you use Ohm's law, V equals IR. So what's the voltage at the battery? 12. Current is what we're solving for. Resistance is 4. What's the current coming out of the battery? 3. 3 times 4 is 12. All good. Okay? And then the third step would be to apply, if you can, the junction rule. And the junction rule says current in equals current out. So in other words, the current splits at junction, okay? So if you did that, 3, 3, 3, 3, 3, what's the current right here? 3, because there's been no junction, right? And then, what happens here? It splits. Okay, what are each of those? Oh, that is correct. Why does it split evenly? Because the same resistance. Good. And then come back together, and what's the current here?
3.
Good.
Yeah, what if they're different? How do we calculate that?
You use proportional reasoning, or you use voltage drop.
Or
So
you
I will give you an example of that. That's a good question. Okay. So now the last step would be to check this with the loop rule. And the loop rule says the voltage drop total must equal voltage drop at the battery. Does that make sense?
I feel like the loop rule's not on the screen for the camera.
It might not be. You are right.
The drop.
Yeah, I did, but thank you, because Julian was saying it's probably out of the camera. It was close. Okay? So the voltage drop, the total voltage drops have to equal the voltage available at the battery. So let's check. What's the voltage drop right here? I think that's on the camera. 6 volts, thank you. What's the voltage drop here or here? 3 volts is correct. And what's the voltage drop here?
3.
All right, so you go around the loops and you see if you get 12. 6, 7, 8, 9, 10, 11, 12. 6, 7, 8, 9, 10, 11, 12. So check. Okay. Now Austin asked, and others, what happens if there's like a parallel pathway that doesn't have an even split? So let's say I have 6 amps of current coming in, and this pathway is 1 ohm, and this pathway is 2 ohms. Okay? So we know there's 6 ohms coming in, and it's going to split, but it's not going to split evenly.
So 2 and 4.
It is going to go 2 and 4, but which one gets 2 and which one gets 4?
1 gets 2. No, 1 gets 4. So,
How come?
because it's opposite. V equals IR.
Because V equals IR, and the current and resistance are inversely proportional. So the higher resistance gets the lower current, and vice versa. Okay? Let me do one more sample, and then I'm going to let you work. Okay.
Break.
Break after this. And now, since this is online, probably don't necessarily even have to
pay attention.
copy this down. You do have to pay attention in class. Oh, dang it. Okay, so this is a classic circuit diagram. I'll make it a 12-volt battery. Is that in the, yeah. 1 ohm out here, 1 ohm here, 2 ohms, 1 ohm, 2 ohms, 1 ohm, 2 ohms, 1 ohm. Okay? We're going to start with 2 resistors that we know for sure the relationship between them, okay? So which 2? These 2? These 2.
Those two seconds closer. Farther, farther. Yeah.
How come?
And then because it's gonna be the same thing around logical.
How come, Justin? They are the same resistance, and
It's gonna be the same.
they can only go one way. Yes, that's correct. But there's no junction between them, right? So we know that relationship. What is that, series or parallel? Series, good. So then this becomes how much? 2. So I'm going to redraw this, and I'm going to turn those into a 2 ohm resistor. One, 2. No, that doesn't happen, John. No. Okay. All right. So now I have made these into this single 2 ohm resistor. Now which ones should you deal with? Ed?
I have a question.
Go ahead.
How do you get 2 out of that? Isn't it just, I gotta know.
Okay. Now which 2 resistors would be best to use? Which one? The parallel 2 ohms where, Justin? At the very end. Very good. What's the equivalent resistance of 2 2s in parallel? 1/2 plus 1/2 equals 1 over 1, and that is correct, John. So this is equivalent to a single 1 ohm resistor. See what I'm doing here? I'm just, yeah, I'm simplifying, thank you, and reducing this circuit diagram every step.
Oh, so it's gonna end up with isn't it just gonna keep repeating that pattern?
I'm thinking it is.
You understand?
Okay, so these guys become, how much?
2.
2. Can we sort of, without me having to redraw every step,
No.
keep working our way
I'm
backwards?
gonna draw it.
You want me to draw it?
No, please don't.
Okay. Let's see if we can talk our way through this. This is 2. So 2 and 2 in parallel, because there's a junction, makes
2.
1. 1/2 plus 1/2 equals 1 over 1. So that's 1. 1 and 1 in series makes 2. 2 and 2 in parallel, because there's a junction, makes 1. 1 and 1 in series makes 2. That's the overall resistance.
You draw that.
Yes. Thank you.
It's just gonna keep repeating the same thing.
Yes, it is going to keep repeating. So the total resistance here is 2 ohms. What's the current coming out of the battery then? Right, 6 amps. So I'm going to go back up to the first one and draw in 6 amps, okay? How will that split when it encounters this first junction? 1 and 6, 3 and 3, 2 and 4.
Or 2 and 4.
Which way? 2 down, 4,
3 and 6.
2 to right. It's a good guess.
3 and 6.
All right. 3 and 6 would make 9.
1.473. And 4.
Yes, there are decimal equivalents.
Oh God.
But it's not how we're going to do this. Okay, somebody tell me why it splits evenly.
That and that equals 2.
Yeah, remember we kept working this backwards, right? If this, so this is 2 and that's 2, that's 1 and 2 and 1 and 2. Hey, it's 2 here, and then it effectively feels 2 out here, right? So that's even. So what's the split right here?
Can you do this kind of like a simplified one to make it easier for yourself?
you could start down here and work backwards, is that what you mean?
1.5, 1.5.
No, okay.
Wait.
1.5 and 1.5 is correct, and then this splits to 0.75 and 0.75. The reason I'm doing this is it'll be really helpful for the, when we do voltage drops. Okay, so now let's do voltage drop checks. Voltage drop here would be 0.75 volts. 0.75 times 1. What's voltage drop here? 0.75. What's the voltage drop here? Thank you. Voltage drop here, 2 times 0.75, 1.5. Voltage drop here, 1.5. Voltage drop here, 3. Voltage drop here, thank you. Voltage drop here, and voltage drop here. Good. 17. 17 is correct. All right. Now, if we go through any of these loops, what should we get in terms of total voltage drop? 12. So let's check. 6 and, whoops, 6 make 12 for that loop. 6, 7, 8, 9, 12, right? 6, 7, 8, 9, 10.5, 12. 6, 9, 10.5, 11.25, 12. Got it? So no matter which loop, we're always going to drop 12 volts. Good?